Foundation model is a really important conceptual term, and it gets used and defined differently, but in general, you can think of a foundation model as a backbone for machine learning systems that gets trained on a very, very large amount of data. And ideally, that data comes from a very wide diversity of sources. The foundation model itself typically doesn't perform any specific task. But what it can do is take new data and create really powerful, compressed embeddings or signatures on that data that allows you to build a new application on top of it. In the computer vision space, it's very common to, first process new images or new videos through a foundation model to create the extracted features for a given data set. And then from there, you can build a classification model or an object detection model or a segmentation model on top of those features. Oftentimes what you find is that a foundation model is trained using either unsupervised or self-supervised training methods. And we think this is another really important topic for folks that are interested in AI to understand. The kind of traditional or historical paradigm in AI that folks may be more familiar with is called supervised training. And supervised learning or supervised training is when you're labeling every single data sample that you place into the model, and then you're trying to teach the model or have the model learn to predict those labels that you've created. With self-supervised learning or unsupervised learning, things work a little bit differently. Typically, you're feeding in just raw, unlabeled data to the model, and then you use these different techniques to try to get the model to learn from the data itself. And the reason this can be so powerful is it's much easier to obtain extremely large data sources that are not labeled than it is to actually pay or find the time to label all of that data. And maybe to draw an analogy to large language models, self-supervised learning has been paramount in kind of the ChatGPT, GPT revolution, where models are really learning to predict the next word in the sequence. And so the label, the thing that the model is trying to learn, is already present in the data itself. And I think people have started to get a really good grasp of what that means, doing this next word or next token prediction. But as it turns out, you can apply very similar principles in the world of computer vision using some different techniques. And so as an example of what that might look like, you could, for example, take a bunch of endoscopy images and randomly blur out a different section of the image and then force a model to learn how to fill in or correct that data where it already knows what the end product looks like. And as it turns out, if you do this with enough scale and enough data, the underlying foundation model, in our case EndoDyno, learns to represent all these different concepts within endoscopy. And so again, the trick is finding the largest data set that you possibly can, even if the data is not labeled. And it turns out the model is able to learn from the data itself how to represent all these techniques within endoscopy. So as just a sense of the scale for EndoDyno, we train the model on a data set coming from over 3.5 billion frames of endoscopy data. There are different curation techniques to kind of pick out the best frames from within that, but the scale there is just truly massive. And that was actually even less than 10% of the overall data set that we've got available. So we're very excited about version 2 of EndoDyno. We expect will be all the more powerful and actually unlock some really interesting new capabilities in GI endoscopy.